So now we're looking at Chapter 8, Systems of Linear First Order Differential Equations. So there's different ways to solve differential equations, which we've been doing. The last method we talked about was the Laplace transforms. Now we're going to be looking at ways to solve it using concepts from linear algebra. And a lot of the application for this type of problems are mixture problems. You'll see this in your circuits class. Predator-prey models. They use this type of system to solve the differential equations. So just in general, we have a differential equation. dx dt is 2x minus 3y. dy dt is 6x plus 5y. And here we have its first order, and we have two differential equations with two unknowns. But we can have a whole system. So that just had two variables, but we can have n different differential equations. Each one has their coefficients. So this is a1, 1, t of x1 plus a1, 2, t of x2, all the way down to a1n. So that's our first variable, a1, and then a2, and then all the way down to the an variable. And at the end here, these f1, f2, all the way down to fn of t, those are going to be not based off of the variable, but that's when we're going to have that non-homogeneous part when we're trying to find our solutions. So we can take that and write it in matrix form. So the first, we have all of our variables, d dt. So all of those variables were taken with derivatives with respect to t. Then we'll have my coefficient matrix. So all those coefficients. And then these are the variables that it was based off of. And then, of course, we have that plus the f of t part, which is the non-homogeneous part. So to rewrite it in a shortcut, we have x prime is equal to a of tx, which is usually just written as ax, plus f of t. So that's for the non-homogeneous. X is our column matrix, which contains just all the variables. F of t is the non-homogeneous system. And a of t, or a, is going to be the coefficient matrix. So I have f of t equal to 0. That's when we have the homogeneous. And then we just have x prime is equal to ax. So I have one. Again, this takes a while to write out, so that's why I just had this out for you already. But write the homogeneous system in matrix form. So I have dx dt is 2x minus 3y, and dy dt is 6x plus 5y. So to write it in matrix form, I want to do d dt of xy, and that's going to be my x prime. And then I have the coefficients. So the coefficient of x was 2 and y was negative 3. So I have 2 and negative 3 for the first row. And then for the second, I had coefficient of 6 for x and 5 for y. So we have the 6 and 5, and these are their the variables that it was based off of. So x prime is that coefficient matrix times x, which is our column matrix. Alright, so I'm going to write some out so we can kind of go step by step. So I want to write the non-homogeneous system in matrix form. I have dx dt equals 5x minus 4y plus t squared plus e to the t, and dy dt is equal to 3x plus 2y plus 5e to the t. So those are my differential equations. So to rewrite it, I want to do d dt of xy, and then the coefficients, 5 and negative 4, and then the bottom 3 and 2, multiplied by the column matrix xy, and then the non-homogeneous part, so I have t squared plus e to the t, And then on the bottom I have 5 e to the t. So I'm going to rewrite it as x prime is equal to the matrix times x plus my f of t. So that was a 2 by 2 because we had 2 unknowns. Here I have a 3 by 3. So I have dy dt is equal to 3x minus y plus z plus e to the negative t sine 2t. Oops, sorry about that. That was dx dz. I have dy dz is 4x plus 3y plus 4e to the negative t cosine of 2t. And then dz dt is y plus 5z minus e to the negative t. So here I have 3 equations with 3 different unknowns. X, y, and z. And then my coefficient matrix. So coefficient of x, coefficient of y, coefficient of z. So I have a 3, negative 1, 1. For the second one, I have 4, 3, and 0 because there was no z present. And then for the third one, I have 0 because there's no x, 1, and 5. And my column matrix, x, y, z. And then the non-homogeneous part. So e to the negative t sine of 2t. And then 4e to the negative t cosine 2t. And negative e to the negative t. And we can rewrite that as x prime is that coefficient times x, which is just the column matrix, plus f of t.